10.5 is about multiplying and dividing radical expressions. Last class we did adding and subtracting. So here we have an example of doing multiplications on example 1. We have two terms multiplied by two terms. So binomial multiplied by binomial. Same thing as other binomial multiplications, you're going to use the foiling method here, right? So you're going to multiply this 2 first, and then outer will be second, inner third, last 2 fourth will be the step of multiplying. So first you're going to get 7 times square root of 5, which is 7 square root of 5. Then outer will be 7 times square root of 2, so you get 7 square root of 2. Inner, you get negative square root of 3 times positive square root of 5. Both value is inside of square roots, so you should be able to multiply it inside of the radical. Last two multiplication is negative square root of 3 and positive square root of 2, so it gives you negative square root of 6. Once you're done multiplying, you're going to see if you can add the like terms. And look like all of this don't have any like terms. This radical, you cannot simplify it any further because you only have 3 and 5 inside, no same value. 2 and 3 inside of 6, no same value. So this is all simplest radical and you don't have any like terms to combine. So this must be simplest form of your multiplication of A. Let's look at the second one. We have square root of 10 times square root of 10. So we're multiplying this first. You get square root of 10 times 10. And when you multiply outer, you get 1 was negative, so it will be negative square root of 10 times 3, which will be 30. And then when you multiply inner, you're going to get positive square root of 30. And then when you multiply last two, you will get negative square root of 3 times 3. So we know that if we have two same value inside of square roots, you can bring it out. It cancels out the square roots. And then look like we have negative square root of 30, positive square root of 30. That cancels out each other. And you have minus 3. This gives you 7 as the solutions. Let's look at C. If we have a square or binomial, we need to make sure we don't distribute. We cannot distribute exponents if you have subtractions. If we have a subtractions, we cannot distribute exponents. So we need to understand that this is going to be same as if we have square root of 3 minus 3 times square root of 3 minus 3. So another problem you need to do FOIL. So first two multiplications is square root of 3 times 3, which is going to be 3. Outer will give you negative 3 square root of 3. Inner, you get 3 square root of 3. Last two, both negative, you're going to get positive. And 3 times 3 is 9. When you combine combine the like term, look like you're going to have 3 and 9 as the like terms. That gives you 12. And then you have negative 3 square root of 3 with negative 3 square root of 3 as the like terms. So you get negative 6 square root of 3. Whenever you get questions on these videos that I'm been sending it to you, make sure to email me if you have a questions, or if you wanted to, we can do the conference from Canvas. If you wanted to try out, just let me know. Email me the date and time that you wanted to do conference. Let's try another one. We have square root of k times square root of k will be k. We have k times negative square root of y. That will be negative square root of ky. And then inner will give you positive square root of yk, but because it's multiplications, you can switch the order to be look like the term before. And then when you multiply square root of y with square root of y, you will get y. And again, the middle term cancels out each other, and you get k minus y remains. What about if we have cube root, different roots, right? So let's look at it. We know that when you have two terms, we cannot distribute exponents. So let's write it. Cube root of 3 n times 5 minus cube root of 3. And first to multiplication give you 25. Outer you get 5 times cube root of 3. Inner you get 5 times cube root of 3. And last two is negative, both negative, so you're going to get plus. Cube root of 3 times 3 will be 9. Let's see if we can simplify it. So you have 25, and then two middle term, you can add it. You get 10 cube root of 3. Don't forget this is cube. And then plus cube root of 9, you cannot reduce or simplify, so that's what you have. No like terms, so you cannot combine any further. Let's look at example 2. This time we're doing dividing. And also we call this is rationalizing denominator 2. Because when we look at this division, first division, 3 over square root of 7, we cannot divide this because you have a square roots. Remember, there was the rules on the fractions where denominator cannot be 0, but another rule is that you cannot have radical on denominator. So whenever you see radical on denominator, you need to be able to rationalize them, which means get rid of the radical from denominator. So that's the exercise we're doing. So whenever you have a one term of radical on denominator, then we can multiply by itself on the numerator and on denominator, right? I mean, we're multiplying by square root of 7 over square root of 7, which is basically this is equals to 1. So you're multiplying 1 to the given expression, so you're not changing anything. But at the same time, you'll be able to get 2 of the same value inside of square roots. So this gives you 7. And that's how you're going to rationalize or get rid of radical from denominator, right? And this only works when you have one terms. So let's look at another one. What about if we have 5 square root of 2 over square root of 5? So look like I should be able to, let me erase this one for a second because I wanted to be able to multiply by, what do I need to multiply square root of 5 to get rid of square root of 5? Having one more square root of 5, right? Two of the same number will cancel out square roots, right? So you're going to multiply numerator, denominator by square root of 5. That will give you 5 square root of 10 on the numerator. Denominator will be square root of 5 times 5, which is going to be 5. And then reduce or simplified, 5 goes into 5 one time. So you end up getting square root of 10. What about C? So first thing I would like to do, like this radical square root of 18, you should be able to simplify, right? So whenever you see radical, then simplify first. Example A and B, I wasn't able to simplify. That's why I didn't go through that step first. Square root of 7, I cannot simplify. Square root of 5, I cannot simplify. But I know that I can simplify square root of 18. Square root of 18 is 3 square root of 2. Again, if you're asking me, how did you get that number, right? Then we know that you have to have two of the same numbers. So 18 is 2 times 9. 9 is 3 times 3. So two of the same number, bring it outside of the radical. And the one that didn't have matching will stay inside, right? We did the simplifying from the previous section, so you should know how to do that, right? Once you simplify, then you decide what to multiply to get rid of your square roots here. So you have a square root of 2 to get rid of. So you're going to multiply this by square root of 2. It means you need to multiply numerator by square root of 2 also. Then you get negative 8 square root of 2 over 3 times square root of 2. So this 2. So this 2 square root 2, this is equals to 2, right? So you had 3 before, and this gives you times 2. And again, before you go any further, you can reduce. So we know that 2 goes into 8 4 times. So you have negative 4 square root of 2 over 3 remaining. And I don't see anything else to reduce. What about if you have negative square root of 18 over square root of 125? Well, again, I wanted to simplify all this radical first. I see negative, so just copy down the negative. It will not affect because it's outside of the square roots. And square root of 18, we just did that, which is 3 square root of 2. And then square root of 125, that's 5 square root of 5. And then now once it's the simplest form, then you wanted to think about what to multiply to get rid of square roots from denominator. That will be square root of 5. So then you multiply that number on both sides. Gives you negative 3 square root of 10 over 5 times 5. Remember, this 2 square root, you get 5. So you had a 5 before. You have 5 here before times 5. What do you get? 25. So let's erase that, and I can write 25. And since 3 and 25 don't have any comments, we cannot reduce any further. That will be your solutions. This time, let's look at the one with the variable. Even we have a variable, we do exactly same thing. First step, whenever we see the square roots or radicals, simplify them. So square root of 50, we know that 5 times 5 is 25 times 2 is 50. So 5 comes out. M to the 4th will be m squared. And only 2 remaining inside of the radical. And square root of p to the 5th exponent is p squared, square root of p remaining. So apply the sections that it was simplifying radical, right? So we get that. And then let's see if what we need to multiply to get rid of square root of p from denominator, right? So in order to get rid of square root of p, you're going to multiply square root of p from the numerator and denominator. So you are multiplying by 1, not to change the given expressions, right? Now you have 5m squared square root of 2p over, okay, so this 2, you get p, times p squared. So p squared times p, you get p cubed. And look like you cannot simplify any further, so that must be it. Example 3, rationalizing. We wanted to deal with different index, different radical here. So far we look at square roots. So what happens if we have a cube root then? It will be the same thing as the first step where you need to simplify them first. So cube root of 27 is 3. Cube root of 16, you have to have 3 of the same numbers. So 3 of 2 comes out, but inside cube roots, you will still have 2 remaining. Once it's all simplified, now you're going to decide what you need to multiply to get rid of cube root on denominator, right? You need to get rid of the roots from denominator. That's rationalizing. So cube root means you need to have same 3 numbers. How many 2 do you have already? Here. How many 2 do you have already? 1. So in order to make 3 more, how many more 2 do you going to need it? That's what you're going to multiply. So you're going to need 2 more 2. So basically you're multiplying cube root of 4, right? So you're going to multiply numerator by the same thing, cube root of 4. Then you're going to get 3 times cube root of 4 on the numerator. Denominator, let's look at this. This multiplication right there inside of the cube roots, having 3 of the same number, this is going to be equals to 2. And you had 2 before. So when you're multiplying that together, it will be 2 times 2, which is going to be 4. Numerator will be same. Denominator will be 4. This one is 3. Okay, cube root. That's how you're going to get rid of your radical, cube root. Make sure cube root you're going to need 3 of the same number. Okay, let's try another one like that. Again, we're looking at cube root, right? Let's simplify first. Cube root of 15. Cube root of 15 you cannot simplify, so we'll stay as, well, let me just erase this. Don't look like, okay. Cube root of 15 will stay as it is because you cannot simplify it. 32, we know that's equals to 2 to the 5th exponent, right? So 3 of 2 comes out. And how many 2 is staying? 2 square, right? 3 came out, 2 will stay in. So this is the simplest form. But then if we wanted to get rid of the cube root from denominator, you're going to multiply by cube root. Have to be the same root always, right? So cube root will be multiplied. And you have 2 of 2 already. You have to have 3 of the same number. So how many more 2 do you need? One more. One more 2. You already have 2. So exactly same thing, you're going to multiply to the numerator. And then what do you get? So cube root of 15 times cube root of 2 is cube root of 30. And this multiplication, radical multiplications. This gives you cube root of 3/2, which is going to be 2. And you had a 2 before, 2 times this 2 will be 4 on denominator. What about if you have a 4th root this time? So let me write this one from here. You're going to simplify it, numerator and denominator, but you have 1 phi, 1 x, 1 z. So basically you cannot simplify it any further, but you can separate this into numerator versus denominator. And see if you wanted to get rid of 4th root from denominator. What do you think you're going to multiply? We know that have to be 4th root in order to be able to multiply, right? Same index. And if you have z, how many z do you need to get rid of 4th root? 4. You already have 1 here. So how many more z do you need? You have 1 more. In order to make 4, you need 3 more. So you're going to multiply by z cubed. It means you're doing the same thing on the numerator. So 4th roots of z cubed is what you're multiplying. Then you end up getting 4th roots of 5x z cubed over this 2. Multiplication is equals to 4th roots of z to the 4th, right? Which is going to be z. So you're going to end up getting z on denominator. Let's try one more time just like that. So the first thing I wanted to do is simplifying, but if you cannot simplify, please separate numerator with denominator. So it will be 4th roots of 6y over 4th roots of w squared. And then once you simplify, you need to multiply something to get rid of square roots. 4th roots on denominator, right? So what will that be? It have to be 4th root, same index. You have 2w already. You have 2w. How many more w you need to have in order to make 4? You need to have 2 more. So that's how you're going to decide what to multiply. Whatever you need, that's what you're going to multiply. Then, when you're multiplying this denominator, we know that will equals to 4th roots of w to the 4th, which is going to be w on denominator. And the numerator will be 4th roots of 6y w squared over w is what you're going to get for that problem. Next example, example 4, we're still rationalizing, but this time we have more than one terms on denominator. We have actually 2 terms. So whenever we have 2 terms, in order to rationalize, you're going to multiply by conjugations of denominator. What does the conjugations of denominator means? For example, if we have, if we have a minus b, your conjugations of a minus b, let me write what that is. Conjugate of your a minus b is going to be a plus b. So the same number with opposite sign between. So in order to get rid of radical from denominator, when you have 2 terms, you need to multiply by conjugations of denominator. So if we're looking at the first problems, 5 over 4 minus square root of 3, in order to get rid of this square root of 3, you need to multiply by 4 plus square root of 3. It means you're going to do exactly same thing to the numerator. So that's the conjugations of denominator. That's your multiplying numerator and denominator. So one term multiplied by 2 terms, you need to distribute, right? 5 to the 4, 5 to the square root of 3. Then you're going to end up getting 20 plus 5 square root of 3. That's what you get on the numerator by distributing 5. Denominator, you're doing binomial time binomial, right? 2 term multiplied by 2 terms. So you're doing FOIL. And previously when we're doing a multiplication in example 1, whenever we have same value with opposite sign, the middle term always cancel out. And I'm going to show you in this problem that it will cancel out middle term. So when you're multiplying by conjugations of denominator, middle term always cancel out. Because this is our first problem, I'm going to show you that really happened. So then first to multiplication is 4 times 4, 16. And outer will be plus 4 square root of 3. Inner will be negative 4 square root of 3. Last 2 multiplication will be negative 3. Right? So then you can see here, these 2 middle term cancels out each other because they get opposite signs. That's the whole reason you're multiplying by conjugations of denominator, so that you will cancel out middle term with the radical, and you will not have any radical on denominator. Then numerator, you get what you started before. Just carry over, not what you started. And then denominator is 16 minus 3, so you get 13. And if your problem is asking you to write it into the standard form of complex numbers, then you can do 20 over 13 plus 5 square root of 3 over 13. So if you want to, you can separate out into the real solution with the imaginary solution. I mean, not the imaginary, rational solutions, right? With the square roots. But again, this format is acceptable on the paper. If we're looking at the same types of problem, rationalizing denominator with denominator being two terms on example B, you have a two term again. So whenever you have two term with square roots that you need to cancel out, you're going to multiply this by conjugations of denominator. So it will be same value with opposite sign. And then you need to do exactly same thing to the numerator. Then you do the distributions on the numerator. You get 3 square root of 5m plus 3 square root of p. Denominator, because this is a difference of square, you get 5 square root of 5m times square root of 5m. You get 5. Oops, let me draw 5m. And middle term will cancel out. Minus multiplying last two term will be square root of p times square root of p, which will be p. And because you cannot combine denominator, that must be it. Okay, let's try one other one. Again, I need to rationalize this. This is divisions, right? I see the divisions. I see 2 radical on denominator. So I need to rationalize this, and because I have 2 terms, I'm going to multiply by conjugations of denominator. That's going to be square root of 5 minus square root of 3. So you need to remember, whenever you have 2 terms on denominator with radical square roots, you need to multiply by conjugations of denominator. Then on the numerator, you do first 2 multiplications, outer, inner, last 2. Right? That's what you get on the numerator. You basically did the foiling because 2 terms multiply by 2 terms. Denominator, you can do FOIL, but you understand this is difference of square. So you will get first term square minus second term square. So you will get numerator, you cannot simplify, so just copy down what you have, because you cannot simplify or combine like terms. There is no like terms. Denominator will be 5 minus 3, which is going to be 2. Okay, let's look at one last one from this section. So again, maybe you can try this one for yourself. Pause this video and try this and see what answer you get. Now, we're trying to rationalize, so you're going to multiply by conjugations of denominator. You multiply same thing on the numerator. And then you will get on the numerator 3 times 3 is 9 plus 3 times square root of 3. So you're distributing monomial into binomial. Denominator is difference of square. So first term square, so 3 square is 9, minus second term square. Square root of 3 square is 3, which you get 9 plus 3 square root of 3 over 6. But here, this problem, it's not done. Why not done? Because you can simplify further. We know this, let me erase this sign right there. We know this is going to be same as having a 2 fractions. Why do we want it to separate out? Because I had realized that 6, 9, and 3, all these 3 number, I have common factor 3. So I should be able to reduce it. And without rewriting like I did it here, some people will say, why do I need to rewrite this, right? You can just do, this is equals to 3 goes into 9 3 times, 3 goes into 3 1 time, 3 goes into 6 2 times. Yeah, sure, you can do that. But some people saying, why are you canceling this 6 with 9 and this 6 with 3? So why are you using 6 twice, right? And this is showing why I'm using 6 twice, because you have a 2 terms, and because you have a like term, you were able to combine it as 1. So if we want to, we can separate it. Once we separate it, then we will say reduce the fractions, right? 3 goes into 6 2 3 times 2 1 time, which will give you that solution also, right?